Hi, Dr. Aman again. So we're going to look the final part for the chapter 5. So previously we have looked on the cascade cycle. So in here we're going to look for the uh, uh, the um, multi-stage cycle. With additional of the flash chamber and the mixing chamber. So refrigerant will be expanded in the first expansion valve, and before it enter to the flash chamber, part of the liquid will be vaporized during this process and then will be mixed to the superheated region. Superheated vapor exit from the low pressure compressor and before it enter to the high pressure compressor. So this is going to be expand, and this is the vaporization. This is split will be in the flash chamber, and mixing will be happen in the mixing chamber. So this is a schematic diagram for the multi-stage compression refrigeration system that we have. So after the condenser, the working fluid will pass through a first expansion valve, and it will enter into a flash chamber where a part of the saturated vapor will go into the um, mixing chamber. So this is a mixing chamber. Okay, and then part of that will, which is saturated liquid, will be expanded into the second expansion valve. So this is EV1 and this is EV2. So the second part of the extension valve will go into the expansion, and then we go to the low pressure evaporator. So instead of it is ended here, so it also will be increased some little bit of the cooling effect. But however, as you can see here, part of the mass flow rate will be divided into two sections. This is a m dot x and this is a m dot 1 minus x. Okay. So as for the low section, low pressure section for the condenser, for the evaporator. So the split here, it has to be properly calculated so that the optimization of the coefficient of performance can be obtained, because as we can see, the coefficient of performance will be depends on the desired output divided by the required input. Okay, so if the amount of the expansion or uh, uh, the saturated liquid is too small, that go into the low pressure evaporator, it will reduce the coefficient of performance, because this effect is not going to be large. So thus what it required is that a suitable amount of the saturated liquid has to be extracted from these conditions. So thus the amount of the 1 minus x is very significant for the multi-stage compression refrigeration system in order to increase the coefficient of performance for the refrigeration cycle. And for the power for the compressor will be evaluated from low pressure compressor and high pressure compressor. Okay, so after exiting the low pressure compressor, it will happen with the separated region. Then the extracted saturated vapor from the flash chamber will be mixed in the mixing chamber here. So and then after that, it will go into the full blast of the flow, and this is a 1 minus x flow. So what will happen here is that it will increase to the full of the flow rate, and then increase the pressure into the 4 section. So in here as well, as we can see, if it is directly from 1 to 4, the required of the power input to the compressor is large, but with this condition it will decrease a little bit of the required power input for the compressor. And however, in here the amount of heat rejected is lessened, so it is not suitable for the heat pump process. Okay, so this is assignment number 4, I suppose, that you have to submit by 30th of May 2020 by 5 p.m. So we also going to discuss a little bit on this assignment during my lecture class. Okay. So this is a third type of the refrigeration cycle, which is known as the vapor absorption cycle. So vapor absorption cycle usually used with ammonia as a refrigerant, and is also contained as the water as the transport system, and then water lithium bromide, and then water lithium chloride systems. So it is an expensive thermal energy source, which is about 100 to 200 degrees Celsius for use for the geothermal energy. And then it's the process diagram for the vapor absorption is given by this diagram. So the coefficient of performance is evaluated by the COP absorption, which is desired output divided by required input, where normally the desired output is the cooling effect, and then the required input is the heat generated and the power input to the compressor. This is another references that you can refer. You can find this very useful YouTube videos that shares by the professionals that you can refer. So I'm highly recommended you also go to this YouTube channel to find an extra knowledge from the other speakers. Okay, so that's all. Thank you very much. Then we're going to have another fifth chapter later on. So thank you.